So, thank you all for coming. I'm going to go quite quickly through my presentation because I prepared a presentation for 25 minutes and I've now discovered it should be 10. So, EcoReFibre project has existed since May 2022. So we've got some way down through the project. So I'm going to skip a lot of the background as to why the project exists and so on, and I'm going to go into more of what we've actually managed to achieve. Monday and Tuesday we had a general assembly for the project. So some of the slides I've got here have come from the meeting. So it's okay for you to see them, but I think the PDF version may be slightly adjusted because I don't have permission from everybody yet for some of the slides that I've stolen. Okay? So just quickly a reminder, everybody knows, but basically we're talking about post-consumer waste in EcoReFibre. So recycling this material, it's been a product and it's end of its life, and now we want to make it into something else. And very approximately across Europe, 50% is burned, 50% is recycled into a wide range of different products. MDF is really hugely popular. That's all you need to know. We're going to the next thing. These are the particles you find on the inside of a particle board. And you can see the pieces of wood. Oops, it's a touch screen.
Mm-hmm. Yeah. It doesn't happen.
Okay, but there is a particle of MDF. Okay, and you don't need to be a technologist to realise it looks different. And so, in general, when you include fibreboard into a particle board, it's not so good. Okay, and the solution at the moment is to put more glue in or press the panel to a higher density to improve the mechanical properties. Both of those things cost. So that's one of the main drivers behind this project. But also, if we separate out that fibreboard, we have to do something with it. We could just burn it, but part of the project is also about how can we recycle that fibreboard. So here's the consortium. I'm not going to go through it all, but it's an innovation action. So it's not so much research, it's about transferring past research into the marketplace. The grey blocks includes the industrial partners, everyone from equipment suppliers all the way through to recycling companies. So we cover the whole chain. You will have the PDF of these, so you can look at these slides at your leisure in the future. So here are the 4 technical work packages. Work package 1 is about providing 2 main streams of post-consumer wood. One is a fibreboard fraction, so this is taking out that fibreboard. The second one is a solid wood fraction, and then the other bit which we're not covering in the project, which is everything else, so plywood, particle board and so on. Work package 2 is about converting those 2 waste streams into 2 types of raw material. Fine, so basically more of a dust type shape of material, and fibres, which I hope everyone knows. And then the third work package is about assessing the quality of these different secondary raw materials by different products. And in the presentation, I'm not going to talk about insulation products. Hopefully everybody knows it. Everyone knows fibreboards, I hope, and everyone knows particle boards. So the only one who's going to get the mention is Eric's bio brick. So I want to give you some results. So in April this year, we had a demonstration of the sorting technology, which worked very effectively. You probably can't see the details in there, but the project is designing a sorting line, and the sorting line involves all the steps you need in terms of preparing the material until it gets to the actual machine that actually does the sorting, which is actually based on OMTRE technology. In summary, we have fulfilled all the key performance indicators for our project. So I'm going from memory, I think we managed 1,300 kilos an hour. I think I can't remember anyway. But whatever the KPI was, we've achieved it. And also the other thing was the purity of the two fractions. The target was 95%, and I think both of them, one was 98 for solid wood and 97 for the MDF. A slight proviso, to get the 97% for the MDF, it has to actually pass through the system twice. So here are some pictures of the material. So this is the input material going in. So the sorting line is going to sort out the fines because they're too small for the different sensors to allow us to separate it. And then this is too big, but the majority of the material is here. And then once it's passed through the machine, there's the fiberboard fraction as taken, and the drop wood, I can't remember what that one is because it looks like a mixture of, so it must be the material we're not using. This picture is a sample, we were all there, Oliver was there. We took a sample of it and we sorted it by hand to check the quality. So it was us, it wasn't Diffenbacher, it wasn't Tom Wright, it was us actually checking, and so we, from that sample, it was 97% fiberboard. So now, what we're doing in the project is actually preparing the material that's needed for industrial trials. So if you need a couple of 100 tons of material, and there's only 4 or 5% fiberboard in the waste stream, that means you're going to have to sort an awful lot of material in order to get the fiberboard that you need. So that's what we're currently doing, and in a way negotiating with the Commission about that. I'm going to skip past this part, which is basically about the work that I'm doing on the consumption of fiberboards. We've got the production data, but what about all the imported material, like a toy like that? It won't be classified as a fiberboard, but it's clearly coming into market. No, skip it. I'm going to skip this. Skip it. Oh, except for the lifespan of products, if you want to take away as a result of different research, our conclusion is the average age of MDF is 12 years. Okay, so a product on average will last 12 years. We can skip that. We've also done a lot of sampling on site to check it, and we're using France as our example country. We've also done processed some samples from our different partners. It involves sieving it and then picking it by hand. Thank God for interns. And these are the results. Basically, France that's 170 samples, 28 different sites, 70 different piles. And the thing we're really surprised about is a very low fiberboard, but that's research, folks. So work package 2, so this is converting those two waste streams into the fines and the fibres by 3 different technologies. There's a dry process system. This has all been demonstrated at the laboratory scale and has been tested at the laboratory scale, and it's pretty encouraging. There's a wet process, which Unilin is probably going to be using in the near future. Well, there's the results. You can have a look at them. I'm not giving you the detail, you understand why, but at least you've got some pictures there. Then the third technology is, can we just use existing TMP? You're asking me to, yeah. And then this is me going fast. Well, basically, IHD have a system that allows us to do that. Okay. Going on to recycling. As I said, I'm not going to mention all the other different board products, but there's just Eric's bricks. So Eric is making a construction brick out of recycled MDF powder. It's organic, it's recyclable, it's high thermal performance, it's very strong. And he has a big container that you're currently converting to make not 8 cubic meters but 9 cubic meters. every 12 hours.
Or a day, but yeah.
Yeah. But, okay, it's still small industrial scale, but it's not laboratory scale. That's where this project is aiming to be. And then everything you do these days, you can't just say, oh, technically this is fantastic. You have to prove it with different life cycle analyses. And the FCBA and IVL are working on that. There's a whole host of different assessments, including social life cycle analysis. And, well, I'm not going to go into detail because I don't know. So my conclusion then, EcoReFibre is working on a real project problem. It's not an academic problem. And with this, some of you who are in the sector will have seen different announcements from Sinai and so on and other people to show that there are other solutions out there because it's a real problem. The sorting technology works, there's no doubt about it. We have tested both fines and fibres in different products, and certainly on the laboratory scale it works very well. Not for every situation we imagine, but the vast majority. I just said that. And so what's going to happen in 2025 are different industrial demonstrations of manufacturing different products from recycled MDF. That's it.
Thank you, Mark.
Is there any quick question for Mark? Yes?
What I didn't really understand is the really high percentage of solid wood that is used. What does that mean? Is it?
No, it was the purity of the fraction, the 97% you're...
Yeah, from other countries like solid wood.
Oh yes, because when you get Class B wood, you've got, for us we've got four main fractions: non-wood, bits of metal, plastic, glass. The solid wood are all the pieces of wood particles, so it varies from 50 to 70 to 80% is solid wood. It depends. So yeah,
Could be that you are, because what Mark is talking about is already pre-sorted clean white wood, so to say, pallets and stuff. That's why I have this high amount of solid wood.
For you, maybe.
Okay, you are using mixed wood.
Yeah, it's mixed. We're only using Class B. We're not using Class A, the pallet wood, because if you start with pallet wood and it works, you can't be sure it works for the dirtier Class B. But if you start with Class B and it works, you can be very confident that it will work with Class A. It depends on the economics. Whether it's
Okay, perhaps it's a question, Eric, what's inside this container and how does it work?
that's a secret. he told me to take out the pick and draw.
But you can come visit.
Okay, thank you very much.
Yeah, thank you, Mark.
And have you ever heard about the magic power of 8 minutes? Well, that's a theory, a concept defended by optimistic people that say that 8 minutes is the time we need to generate genuine connections between people and whatever place. When I held this session with Ricardo here, I enjoy because it's like that. Well, we talk about connections, and this is the office, our headquarters in Santiago de Compostela in Spain, and we have also called connection to this building because for us in our company it's really important to generate connections between people through our community. And we talk about 8 minutes, but I don't know. And every day in our company, every 8 minutes we process 8 tons of recycled food. I don't know really if 8 minutes or 8 tons is too much or too little or even enough. What we really know in the panel industry is that to grow 8 tons of wood through pines, it requires a lot of soil nutrients, rainy days, sunshine and a lot of effort in taking care of the forest. So as we know the value of the forest, we understand very well that put this again in the value is really important. And let me introduce myself. As Kris has said, I'm an architect and timber engineer involved in FINSA for 20 years now. And well, I come from in the northwest of Spain, in Santiago de Compostela, that everybody knows because it's where pilgrims end their journey. There in our region, forest has always been a resource of incalculable value. It is precisely for this that forest has deep roots in our culture, that we take care of the ecosystem. Keeping this ecosystem alive requires a lot of effort. And with that in mind, we were motivated to extend the life cycle of any particle as much as possible. So with that in mind, we decided to begin to develop a particle board for construction purposes. This is our starting point. Is a patented process by FINSA in a factory we have in the middle of Portugal. And there we can produce a particle board with MDF or fiber in phases in a 5 layers formation, as you can see here, where we can introduce, of course, as any other particle boards, recycled wood. This chipboard core with fiber phases has a very good mechanical behavior. So 10 years ago, we began with a long structural characterization process of these Superpan boards. You can see there how is the profile, the fiber, so it's good for mechanical properties. These tests were carried by the University of Santiago de Compostela. It takes initially more than 2 years. And afterwards, and as our first client were large industrialized timber construction companies in the northern Italy, they told us about the advantages of using also this board, the Superpan Tech, for passive houses, because the faces are really good. So we decided also to certificate the Superpan Tech at Passive House Institute in airtightness. So we finally had a certified wood base panel prepared for use in timber construction system frame and a load bearing capacity. Let's take a look at some buildings where this panel is being used. Are all timber construction buildings in Spain, most of them. It has been used mostly in this type of houses, unifamiliar houses, where the owners are very committed to sustainability and the use of timber, of course. Many small and medium-sized companies are emerging in Spain doing this kind of construction. There's still a small network based on digitalization. Most of them are installed in rural areas through all Spain. This is, for example, in Barcelona. Not only houses, but also schools like this one, or healthcare centers or commercial buildings have been built during these years, or even in renovation in urban areas is being used. Well, let's take a look at the process. This could not be possible, of course, constructing like this in Spain without a lot of work in the initial process of the projects, because it takes a lot of time to collaborate with civil engineers, architects, developers, construction companies that have never been used timber when they construct, so it requires a lot of effort in initial stages. A lot of conversation to understand how to put this into on-site. And the process is possible today because of digitalization, because all the people involved resolve the project digitally, and then you can robotically construct it. Here you can see how it was constructed, this native house that is located in Mallorca, here at the factory. Now the panels goes on site. As you can see, it's a network through Spain. We produce in Portugal, do some works in Galicia. Afterwards in Alicante is making the panel, and finally in Mallorca, some European build the houses. So there you can see how it was built, a general view of the organization during the process of construction. Here with the elements, wooden elements selected, and the final result of this organization. And the interior. As you can see, the interior is not different from other houses like others that are constructed with other materials or processes. That's not the difference, but the main difference, in my opinion, is that this house can tell that it's constructed with timber, so inside is extending the long life of wooden for almost 50 years or more, even recycled wood, because it was constructed with our panel. So circularity and bioeconomy is part of our industry, and as circularity, in my opinion, is about retaining value. Sustainability is about keeping the most this value. And to finish, just I would like to share with you a little reflection. This is Madrid, could be any other city, but this is where we live, our habitat, and I just can say that statistically just 2% of the construction you see there has been by this way, like the houses I have showed to you, because statistically timber construction in Spain represent nowadays just 2-3% of the total amount of construction. So you can understand that people who build with timber is really great people encouraging resistance to change. But we know, and recently we have the consequences that changes comes anyway. So the most effort has to be put into involve more people from construction value chain to this kind of practice. And with that, that's just thanks for your 8 minutes attention.
Thank you very much, Emma. I think we have time for 1 or 2 questions. Yes, please.
Yeah, could you say something about the inflow? What percentages of what type of woods do you use?
In the board,
Yeah.
we certificate at least 30% of post-consumer wood to be recycled. In other factories we have even a bigger percentage, but in this case for this panel it's 30% of post-consumer.
And the rest?
The rest is particle from, well, we manage a lot of forests around the factories, and there with the manage and the take care of the forest, we do, I don't know how to say in English, but well, the branches and so on to make particles.
Okay, because I also saw in one of the images a pile with pallet wood, for instance. Is that also something that ends up in your?
In these pictures are from a factory we have in Teruel, in the middle of Spain, and there's a lot of logistic companies installed that when they finish to use the pallet, they give it to us to do. But there we produce MDF.
But do you know of the innovation that you can use pallet wood on a much higher grade? You can use CLT panels, for instance, from this now new innovation. So is that something that you take into account, that you kind of shift your inflow
Yeah, we of course, we would like to, but step by step, and we are always paying attention what we can do better.
But that's part of the whole process.
Yeah, it's part of the whole process.
But you have to take into account that CLT is a new product and it's put in big houses. So by the time this becomes a waste that it can be recycling, it will take a time. But obviously recycling it into particle board should not be what I think it's fantastic raw material for using in particle board. So at the moment I think it's mostly outfall from a CLT construction where they make a certain frame and take a part out that is already being used.
Yeah, but it could even be argued that there is a low-grade application.
Yeah, exactly.
Yeah, of course.
But we're investigating in our factories from the how do you call it? Dust to create a new panel, lower quality panel, but with dust of the factory. So, I mean, as Emma is saying, we are continuously investigating, but sometimes you don't have the volume to. It's not enough.
The journey never ends.
Yeah, but we don't stop.
Well, in general, there are seven grades of particle board, all quality grades.
So I call it MDF closing the circle because in a lot of cases MDF is still considered non-recyclable, which is actually a threat to this product in the long term. We have some examples here. For instance, leading retailers do have a kind of what they call a product sustainability index. This incorporates recyclability, recycled content and so on. And you get a score. Another product can have another score. MDF, if it is considered non-recyclable, will have a bad score, and the retailer in the end will choose another product. Same thing for architects and designers. They choose more and more based on sustainability, performance, sustainability parameters. And finally also, for instance, cradle to cradle. If you want to have a cradle to cradle certification gold, you must have post-consumer recycled content. If not, you cannot reach quality. So that's why we said, okay, we need to work on that. We need to make sure that this stigma disappears. So I will go a bit faster. I only have to condense 15 minutes in 8 minutes. So that's not the new mark. I was good. Okay, this is what we want to do. We go from the linear to this one. And actually, okay, one of our products is laminate flooring. It can be any MDF-based product. We use virgin wood. At the end of life, we will extract the fibers, and then we use them again and put them back into the process. This is what it basically is. What is the challenge? The challenge is, again, you can take any MDF-based product. It can be laminate flooring, it can be part of a cabinet or whatever. It has a baseboard and then it has some finishes. Finishes can be varnish, can be coating, can be laminate, can be whatever. And the baseboard is roughly 80% wood fibers, and then the other 20% will be glue, additives, and some moisture. What we are interested in this part, we want to take this back and reuse it in a new product. So not downcycling, but really reuse it in the same product. The challenge is how to do this. The most easy way is to do as in particle board, you just shred it. By shredding, in the end, you have fibers that are damaged because, of course, the mechanical action damages the surface and you will have a poor quality. So this was not an option. And that's why we developed, it's more like we put to work a steam explosion for this application. A steam explosion is the way you put everything in a pressure vessel, you put it under high pressure, and then you depressurize very fast. What happens is the steam is expanding and actually explodes more or less the material. The fibers are unharmed. You can see a picture here with a magnification with an electron microscope. The surface seems very fine. It is quite gentle to the fibers, and we can reuse them again into a new product. We call the technology Osiris. I think that Veronique this morning already explained that. This is the... Okay, now, can somebody tell me what it was? Okay, thank you. So then we put them back into... We did lab tests first, using these fibers, so small scale, up to 100%. And actually we can produce boards with it without major impact on quality, meaning Sometimes you need to adjust a bit, but anyway, you can produce boards conform with the standards. That's why I could say that, okay, ESB is cost effective and is a solution for the circular economy. I still will explain the cost effective, because the difference between using virgin wood and this recycling is that if you want to transform logs into fibers, you need a lot of energy. To explode, steam explode, you need much less energy. And it's really this difference, this balance that makes that this technology is cost effective, because it uses much, much less energy, especially for the fibering part. And then of course, the rest of the process, once you have the fibers, you mix them with the other ones. This is standard. Where are we? About 2 years ago, we started building a pilot line, and this was actually in the framework of SISIFLO. SISIFLO is another European project, stands for Circular Sustainable Flooring, and part of it is the recycling of laminate flooring, other part is recycling of carpets, vinyl, and so on. So for the part of laminate flooring, we have built this pilot installation that is running now at about 1 ton per hour, 24/7. And this was actually the vehicle to debug the technology. So to see how do we need to do it, how fast do we need to expand, what pressures, how do we need to clean the fibers, because I will come back on that. And then this means these fibers are used immediately, re-injected into one of the production lines in the mill in France in Bazet, meaning that we go up to, depending on the product, up to 5% of recycled fibers in the mix. And this is running fine. So far, no customer complaints. Honestly, if I would give you 2 boards, you could not distinguish between them. Of course, it's also linked to the 5%. And if it would be more, you would see it. The main difference is that the fibers are slightly darker. And if you do the steam explosion too slow, they are much darker. But they're slightly darker, so you have a small visual effect, which is more cosmetic, I would say. It has no impact on the characteristics of the board. We started off using mainly internal waste, because this is easy. You don't have contaminants, you have no pollution. Oops. Yeah, that's a touchscreen. You have no pollution, this is working fine. Now we are working on pre and post consumer. This is working fine as well, but of course the challenge there is how to clean the fibers afterwards. There are solutions for that. It's sometimes a headache, especially when the dimensions of the contaminants are in the range of the fiber dimensions. Then it's getting very critical, but in most cases it's quite easy to separate them. So this technology is working fine. We decided to invest in a 10 ton per hour installation. Actually, the investment has been announced a couple of weeks ago in the mill in France. The project has started and it should be running by the end of next year. No, it will be running by the end of this year. Cut it out, please. And the final goal, or not the final goal, but the goal by 2030 is that we would like to expand this technology and have 25% of our fibers being recycled fibers based on this technology. Voilà.
Thank you very much, Geert. As EPF, we are also a partner in SISIFLO. So because we really want to support industry as much as possible, so not only EcoReFibre but also SISIFLO, and I think SISIFLO is running a bit faster than EcoReFibre, so I think it gives a good example.
We started a year ahead of it.
Exactly, yeah.
That's the only reason.
But, and now in EcoReFibre also there is the shift from the easier fraction, the pre-consumer towards the post-consumer, and the European Commission is insisting on that very much. Any questions to, yeah, Erik?
Yeah, just wondering, this laminates on top of it is a problem. Do you take them away before the steam explosion? Or
Actually, we leave them in, and then the process by the steam explosion separates them, meaning that you have fibers with flakes, and the flakes, let's say the coatings are more like flakes in between the fibers. Then it's just a matter of separating the flakes from the fibers. So we don't need to let's say sand or whatever, to take them away or to take them off before the process.
Okay, yeah, question.
I have a question to the post-consumer material. I guess if you run 10 tons per hour, you will not have enough waste material from your own line, or maybe
If you would have enough, then we would do a bad job. That's for sure.
how do you organize to get this material?
Well, this is
if I have in mind that it is only 4% of an
This is actually, we have a network of recycling. That's our, Unilin is running about 100, we're running on 100% recycled wood in particle board. So we have this network. This network will be used also to recycle or to get the input of MDF. It's a matter of course, learning to them how to separate it, to have separate bin and then to handle it. This is one thing. We have also collaboration with customers that the offcuts that they can put them in a separate bin and we take them back. We have it in our internal days. But this is a headache, but not my headache. I'm working on the technical part. But indeed, it's a challenge.
Yes, Kris.
You're recycling the fibers, which is already fantastic, but I saw that in the MDF panel there's also 10% of glue.
Yeah.
So if we recycle 10 tons per hour, that's 1 ton of glue per hour that comes out of the old MDF.
Yeah.
What happens with the glue?
Some part stays on the fiber. So the glue, it depends on which type of glue it is. If it's urea formaldehyde glue, you hydrolyze it for a big part. So some part stays on the fiber. Some part is evaporated with the steam, so you have to treat the steam. And some part is in the condensation, and you have to treat the condensation. So it's partially still there, but the part is gone. But you need some treatment afterwards.
Okay, one last question.
Is it a technology that also other companies can use? Is it open source? Or?
Well, if you know Unilin, we like to sell licenses. The technology will be open and is to everybody who is interested. You can always take contact with our department and then we can look further on that.
Okay, thank you very much, Geert.
I'm gonna make like a jump from recycling to reusing and from panels to systems, because we have been talking a lot about recycling, and I have a question to all of you. We can answer afterwards, or we can talk about it. But do you think it's enough to recycle? I don't think it's enough recycling things. There's a deadline for that also. So we have all these challenges, no? I mean, we already talked about them this morning. These are European challenges and construction challenges to traceability of materials, life cycle of a building, digitalization of chain and maintenance of a building, and bonus plus buildability for using sustainable materials in construction. No? But in Spain, at least in Spain, we have other even worse challenges, added challenges that we don't have. And we have a deficit of 900,000 workers on traditional construction. We have, in 25, Spain will have a deficit of 600,000 apartments, units, in 1 year and a half. And it's not solved. We also have bigger problems of financing housing in the traditional way. So that's a problem also, no? So we believe that, we believe, as I was mentioning, that recycling, of course, it's necessary, but it's not anymore enough. We must think on designing for reusing. And the only way to reuse components in construction is designing them to be installed and uninstalled. And when you design an industrialist component, you design not only the industrialist component, but the process of using it, monitoring it, and reusing it, and installing it again. So you have to think in the whole process. That's why this is a real circular system. But of course, always using wood as part of the trigger of other materials. And how we believe we could, 4 years ago, how we were able to do that? collaborating with other companies. We could not do this anymore alone as FINSA. That's why we got together with a lighting company. ZICLICK, it's a family-owned company with more than 100-year-old history. They are from Barcelona. They produce lighting systems, and they produce sustainable lighting systems. For example, with LOD, LED, organic LED. So we got together and we thought we must accelerate the processes of interior finishings in this massive volume of renewing of housing. And the first problem to solve was the timing, making everything faster, and we decided to create a company and a brand that designs and produces circular systems for interiors in buildings. It's called ZICLICK because it's ZICLICK from cycle and click from industrialized system. ZICLICK is born to design and implement industrialized systems using fiberboard and woodworks in interiors of buildings. It's created to be able to make circular systems around buildings, and also it's created to be a company that will be able to produce systems to be reused and to be installed in other buildings. This is the first system. It's called ePanel. It's an MDF board, but the particularity of the MDF board is already designed with all the electrical components to be installed and uninstalled, and it's a plug-and-play system that integrates electricity, dimer, lighting, and sensors. So every panel is one element. For us, this is a system. It's an industrial system. You can see this is an example. This is a real project. We work for this big servicer of colonies in Europe. It's called Urban Campus. This apartment, of two-bedroom apartment, they needed to do an installation on only one morning in 2 hours. So we only found this. They went to their jobs. We came, and in 2 hours we had everything already installed, and we didn't have to send a carpenter, an electrician, and anything. So another important fact is the financial part of buildings. You know that in buildings there's a part of CAPEX and one part of OPEX. All the interior renewing of buildings, co-livings, hotels, all these, I will say buildings that have to be managed during a period of time, all the expense is OPEX. So this is an OPEX product. And why it's an OPEX? Because it's circular. And we can use it many times. Now you can see how fast it is. Everything is integrated in every panel. So imagine hotels, holidays, everything. And we don't stop there, because what you saw is the design of an industrialized system for interior. But this is the digital part of it. The digital part of it is proposing that we will be able to create digital twins of the panels in the buildings. We have been talking with many investment funds, and to digitalize a whole building that was built in the 40s or in the 50s or in the 60s, it's impossible. There's no time and there's no money to do that. They will only digitalize or create a digital twin of the building step by step. Once you start doing refurbishment, facade, part by part. So what we believe is that we have to create our own digital twins of our panels and geolocalize them on the buildings of our clients. So this will permit us to have a database of all the panels that we are tracing them on BIM technology. We will be able to geolocalize all these panels in the buildings we are installing them, and we can tell the operator of the building when they can reuse them to another building after they use those panels and they want to use it in another building. So this is circular economy and circular service at the end. There's a process of course, of validating all the panels, knowing where we have to reuse them into a local warehouse, and then with electrical urban vehicles we can move these panels around European cities. And at the end, we are not going to stop there, because ePanel is it's a finishing of a wall needed in renewing buildings, but we want to continue with partitions, we want to continue with ceilings, always 2D solutions using wood panels as part of the core of this system, but always integrating other systems as electricity and lighting. And at the end, I like this phrase of Henry Ford because innovation without execution is hallucination. So, thank you. Any questions?
Thank you very much, Jacinto. I think your presentation is really an excellent example of the spirit
Yes.
of the new European Bauhaus,
Yes.
cooperation with different partners to come to new solutions. So
I think we have to integrate not only the industry, but also the developer, the architect. I mean, we like it or not, we are in the construction industry. The construction industry is the real estate industry. So, so I think that's part of it.
good. I guess there will be some questions. Yes,
Fire properties?
Sorry?
Fire properties?
Yeah, this is already tested because our panels are already tested to fire rating, and all the systems, the electricity systems and lighting systems, Simona already tested everything, and the whole system is already tested. The substructure, the lighting, and the panel. So it's the one essay for a whole system, no? So yeah.
More questions? Yes, please.
How do you deal with different application requirements from one use to another? So I understand it's the panel and the lighting, but what happens if you need different sizes?
Yeah, I mean, normally, this is a standard system. It's 90 by 230. It's already thought for some applications, some buildings, for example, hotels, common areas. We can reach up to 280, depending on the project. But we like to answer this in projects, saying if you want to do a perfectly handmade finishing, just hire an electrician and a carpenter, and that's one thing. This is a system, and this will solve maybe 70% of the necessities in buildings.
So you need to work with the providers of
exactly.
systemized buildings.
Exactly, we have to be very integrated because besides this, FINSA is producing CLT in 2D, facades, everything into this, so we can integrate this 2D layer to a CLT panel also. So at the end, it's a matter of thinking on components. So it's like, it's more designing buildings in components than in...
That's why you can't stop there.
Exactly, we have to continue. We have to think that 2D components can be in the interior, can be in the facade, and so it's part of it. Yeah.
Thank you for this presentation.
You're welcome.
Which surface technology are you using on
Sorry,
this?
sorry?
Which surface technology are you
The
using?
surface technology of FINSA.
Can you repair and refurbish it?
That's a very good one. And yes, we will be able to, because we are thinking on new surface for the panels. And part of these panels, first solution is when one of these panels is not working in a hotel, time is money in hotels, and we can take out the panel that is not working or has a damage, or the electricity panel is not working. We take it and we recover with one, and then we take it to our factories and we see if it's an electricity problem or it's impact, and we can repair it on off-site. And the whole electrical line still works because the system, the electrical system is on the back part. So the rest of the panels will continue working. So you don't have to close your activity as a business, no. So we can repair these panels with a carpenter in a factory, and also the electrical part. But we don't send no one on site. So that's part of it. Yeah.
Okay. Yes, please.
Who's the owner of these panels? Do you sell them or do you rent them?
No, that's a very good question. In fact, I mean, we did our business model thinking on selling them and reusing them many times as an OPEX investment, but we have the idea of renting them. In fact, we like to call it product as a service, because the fact that you can rent something and you can manage the renting system and then take it up, deliver it to another building, for us it will be a business. But industries, construction is still not prepared for this. I mean, but we are already thinking on that, yeah, and that's a very good question.
But if you sell it, you have to rebuy it later on.
Or not. I mean, at the end maybe, or no, because another company or servicer, for example, another hotel company can buy it to that hotel company. So and we can connect them also. So that's the important thing, because we work as an industrial company. We work very, very connected to investment funds and developers, because they want to know what are our solutions, what do they have, what warranty, and so I think the most important thing about this is to continue tracing things. And the problem we have now is that we don't trace things. And if we don't trace things, we cannot trace things. So, it's a very good question.
One last question.
For the rating system, is it something that you found on the market, or did you develop something?
Some parts, yes. There were standard substructures, we already found them, and some of them we designed them. We designed them and we printed in 3D, in aluminum. So, for example, all the fixings of all the electrical and lighting part, we designed it in 3D, and it's only for this system. So if you take out those elements, you cannot mount them.
Support on the wall.
Yeah, the support on the support on the wall. The substructure, yes. The fixings, no.
Okay.
Yeah. So, and this is not a patent. This is a model OMTRE, utility model. I don't know how to call it, but it's enough for us. I mean, we want to go to the market, start changing the market, and if they copy us, perfect, because there's market then. So, thank you. Thanks a lot.
Thank you very much.
You're welcome.
Thanks for being here, joining us. This is a bit different, but we have some similarities, of course. So that's what I would mainly talk about, but our focus is the reuse of the solid wood. I just started here because this is also what the UN says, of course, and this is the circularity principles of avoiding first, not rebuilding, and then shifting to bio-based, and then at last improving what's fossil-based. So SirkTRE, our aim for the Norwegian market, we have 800,000 tons of reclaimed wood, which is known as reclaimed wood, waste wood. It's more, but then it usually just directly goes to incineration. But this 800,000 tons could directly be used, or not everything could be used, but today it's incinerated about 90%. Actually, it's the highest quality of waste wood in the world, and we should not burn it. Our goal in SirkTRE is to use half of it, put it back in building products, not only as solid wood. We aim at between 20 and 25% solid wood reuse, and the rest will be wood chips. But if we manage to do that, it will account for 8% of what we have agreed to reduce our climate emissions in the Paris Agreement. So it's huge potential just in the reuse of the waste wood. And the good thing is that when we haven't designed what we mean with the new full value chain, we have partners in all these aspects, all needed, and the difference between the normal value chains and the circular value chain is that we add the mapping and we add the demounting, and that's something that we've learned. You cannot use the waste wood directly because the quality is not good enough. We have to demount. This is a 4-year project. We got about 10 million euros, and in total it's a 20 million euro project, and it's only in Norwegian. 1 year left. And this is how it's built, and it's in Norwegian, but I'll just run through it quickly. It's also got a sister project, a research project, which we call SirkWood. And what they do, they trace research, what we are doing, and they have these work packages, and Lone is heading this. Lone is also here from Review. But what we do is solid wood. Research is actually led by Erik. It's on wood chips and also reducing the amount of steel needed. And for the last, we have the test bed. I'll focus mainly on standards, which I mentioned earlier as well. I'll tell you where we are standing, and also I'll show you some of our results. So this is how I intend to show the results. And Xavier, you also know some of these results. It's from the Icebox Challenge. We have a lot of results, obviously, and also I put in some EcoReFibre blocks, which you put in first, Erik. But of course, we have the design projects that aim on more flexible and longevity in the architectural aspects with this framework projects. Most likely it will be first realized in Australia and not Norway. This is a school, 2 schools that will be rebuilt as a big kindergarten. We have sound walls for office buildings, actually several of them. We have marketplaces, and we have some pilots, as I said, and also this robot lab, and we have also developed new connections, connections which can be used without that much steel. Then the standards, very quickly here, I also stole a bit, Mark, from the new circular construction standard that Sam is developing at the moment. Of course, we are lucky to have the ISO 59000 series, which is the overarching circular economy standards. And we are also happy to be a part of circular construction that's being developed in big with SAN and also within the harmonization. But we are able to do our own standards regarding reuse of timber structure and reuse of timber components. And so far we have finished 3 standards. So this is on evaluating return wood, how we define it and the general rules. And the most important is the visual strength rating. Next, we are working on combined structural timber projects like glulam and CLT and nameplate structures, how they can be turned circular or reused, if they can be, I'm not sure. And also the competence requirements. So those 2 standards will also be finished within SirkTRE on the Norwegian level. And then our list is much longer, obviously, because it's a lot to do. The title is New Businesses Within Reuse of Timber, and this is a blue ocean because it's so little done. Although, long time ago, or not that long ago, log buildings, this is circular economy for sure. But what we aim on first is the design for reuse, or the design for demounting. And actually in Norwegian technical building regulations, this is now a requirement. So we have to build design for reuse, but we don't, because we don't know what it means. The vision of us in OMTRE is to meet 30% of the timber demand with reused wood as a sourcing material. Not alone, but we think this will be the case in not that long, and that's due to a growing market, and it's the only way that we can meet this growing market. And we try to identify and commercialize some of these ideas, and one of them is patented. We call it the reblock, and it's been built 4 or 5 pilots with this system, and now we're doing a pilot production. Good. So this is it from me. Yeah.
So I'm also from OMTRE, and I'm using a different visual identity because after SirkTRE we got 2 more horizontal projects, and also starting this month an EIC Pathfinder Challenge project with Stuttgart University. So I'm kind of responsible for European projects, and they asked me to use the slides. So I need a picture in the slides. Okay. So the clean timber, I'm going to explain a bit differently. I made a couple of boxes, screenshots of our website. I don't know if the QR code works here in the beer keller. No, so yeah, I'll share the PDF later. So actually reuse is already done for thousands of years, globally on a small scale, but we want to we want to bring it back and make money. Because that's like a question, like how we actually make money of the civil economy. Like in DRASTIC, we work also with Saint-Gobain, big construction company, and actually all technology is okay, but the business model, that's a big question. So I'm going to tell you how we're all going to get rich off reclaimed timber in 10 years. We'll see, we are learning step by step. So for me, OMTRE started as a low-tech startup. And now, like Kristine said, we want to be a production company. One of the things Kristine already mentioned is reblock. Like you can build your own sauna and relax. It's like an ecosystem, it's very relaxing. We know as children, and now you can do it as an adult. We also have made, as another actually example from SirkTRE, a barn. 75% of the walls is reclaimed timber. And the cow's already there for 2 years. I'm very happy. So, very happy clients. So yeah, we also like, I'm going to go very quickly through this. So we want to like set up a business, but that's a whole policy landscape. And my approach to this is not coming from engineering. I actually come more from system science. So I'm very interested how we're actually going to play with the cards we have. So we understand there are like many things happening on European level, national level, and Norwegian level. And the story is how is OMTRE navigating in this policy landscape. I'm going to try to go very quick. I can talk for 5 hours about this, but I've only got 5 minutes. So yeah, for us in OMTRE, what I also really do a lot is like looking into the ecosystem. And we're just going to go quickly through this. And when we actually started some years ago looking into ecosystem, we see there's a missing actor. And we call it the resound mill. I'm going to like repeat this word a couple of times because when you repeat the word 7 times, I think, it sticks in people's mind. So 8 minutes and 7 times mentioning the same. So in OMTRE, we're really interested in this kind of resound mill, which is like a processing center for reclaimed timber. And I always like compare it to a hospital. You know, when you like enter hospital, you're a young patient. I don't know. Actually, I always want to be a doctor, but now I'm a doctor for trees. You have to like make different decisions, and very quick, as a doctor often. Like rapid diagnosis, rapid sorting. You go to this department, you go to that department, and that's going to be very important for us. Rapid decisions, rapid sorting, rapid diagnosis, rapid treatments, rapid delivery. So like a lot of questions that we're like trying to look at all these different parts in Europe and also in SirkTRE projects that we want to like do to make this cost effective. So we're also mapping a lot of problems. So we look at different phases. We don't only look to production, we also look to sourcing, preparation, pre-production. There's so many questions to solve, and every question, the way I make decision, that's going to influence your cost structure. So we like to take this very big systemic approach. So yeah, this is like a typical life cycle that we want to kind of push in the future. So this will be like the resound mill, the hospital. So this is like disposal. So for example, wood waste can come from very different ways. It can come from deconstruction. Maybe some pre-sorting. Which patients can go to you guys? Which patients go to us? And now you have like different aspects, scanning for materials like metal, fungi, you know, and like all different kind of steps until you can bring it back in construction. And some parts will be a lot of value creation, but also comes a high investment and operation cost. So we didn't talk really that much about how expensive are the equipment. I don't know how much you know how expensive like metal removal is. I know the labor costs. I know how much 12 in OMTRE is leading to like.
I don't know what time is it.
Yeah, so I'll go quickly. So it's a lot. So we like looking into this, and we just like try to look in different kind of configurations, and also look into logistics because we also like talking. Will we like scale up or scale out? So we also more and more go into like logistic choices and making this kind of choices. And also, of course, we also have to do a lot about change management because we work with people. I come myself from a family of only truck drivers and construction people. I know how they sabotage a scanner. So I know we have to work with these people too. And we like involve them. So like a couple of C's, which we also try to like integrate in our horizontal projects, especially impact working packages. And we get on to the loan. And these are actually my discussion points for a panel, but I think we don't have time anymore, so that's it.
Thank you. No quick question. Okay, well I hope you get rich in the next 10 years. So I think that was
all of us. But rich in quality of life. Yeah.
So Oliver and I were supposed to conclude. I think my conclusion is short. You see that circularity in the woodworking industry already exists, and you see that a lot is going on to make it much more circular and to also move, advance from where we are now, being mostly recycling, into also reuse concepts, design for reuse concepts, even reuse in solid timber. So I think, I hope you find that we are on the right track, and yeah, all the time we are available for questions. So Oliver?
Just saying that it's a long way, as we have seen, many challenges to conquer, so it's like a big adventure, but always when you do adventures, you discover new things, unexpected things that you didn't see before, and hopefully a lot of opportunities to become rich.
So thanks to all the speakers, thanks to all of you, and coffee is upstairs.